Hello again, this is the Pencrest High School AP Physics 1 video series. This is video 6B, one-dimensional impulse and momentum. Now the first thing we're going to look at here is one-dimensional momentum and impulse. Recall that one-dimensional motion is constrained to travel in one direction or the other, or its opposite. Think back to one-dimensional kinematics and the train tracks that only allow the train to move to the right or to the left. Same sign conventions apply to momentum and impulse in one dimension that apply to the other vector quantities that you're familiar with, position and displacement and velocity. The sign convention is to the right is positive and to the left is negative. It's easy to see how the momentum at any particular time would have a physical direction to the right or to the left. Of course, that direction is associated with the velocity of the object at that time. What's not so easy to see is that impulse also has a physical direction. The change in momentum either points to the right or to the left. Now we can think conceptually of the impulse as either increasing or decreasing the magnitude of the momentum, the same way that acceleration does to velocity. So, in other words, if the impulse points in the same direction as the momentum, then the magnitude of the momentum increases and the object speeds up. And here we see an initial momentum pointing to the right. There's an impulse to the right, and the final momentum gets larger, has a larger magnitude because the object is moving faster. Now, if the impulse points in the opposite direction, the magnitude of the momentum will decrease and the object will either slow down, or if the impulse is big enough, it'll change direction. So here's my initial momentum to the right. There's an impulse applied to the left. The object slows down and its final momentum is smaller than the initial momentum. If this delta p were even larger, it could conceivably turn the object around and make it move back to the left. Now here's a simple example of making some calculations with one-dimensional impulse and momentum. The major issue here is you got to keep track of the signs. So we have some data. We have the mass of the object here. We have the velocity here, the initial velocity. We have a time interval, and then it tells us that this much time later it's moving with some other velocity to the left. So again, before we make any calculations, can we draw any conclusions about the impulse? Does it point to the right or to the left? And how can you tell? So again, if we look at the initial velocity, which is to the right, the final velocity is to the left, the object changes direction, which means the impulse must be pointing to the left. Okay? Now, in terms of making the calculations, we know how to do momentum. The initial momentum P equals m times v. There's my initial velocity and my mass. The final momentum is the mass times the final velocity, which is to the left. We've got to be careful, again, that we make this velocity term here negative. So my final momentum is negative. The impulse is final momentum minus initial. So again, we've got to be careful that final momentum is negative minus the initial momentum, which is positive. We get a very large negative quantity for the impulse. And finally, what is the applied force? Applied force, we know force is a vector as well. Delta p equals F times t. Therefore, the force equals delta p divided by time. We have the impulse here, negative 945 Newton seconds, divided by the time interval, and that gives us the applied force. Again, this is pretty straightforward. The major issue is keeping track of the signs. Okay. Again, we see that in this case the object changes direction which indicates that the impulse must be in the opposite direction to that of the initial momentum. The initial momentum is to the right, impulse is to the left. Okay, again, pretty straightforward for one-dimensional impulse and momentum. Next up is conservation of momentum, and then we'll move on to collisions. Until then, enjoy, and I'll see you soon.